Okay, so what we're going to look at now is actually a really tough concept to wrap your brain around sometimes. So we're going to start with an introduction, a little bit of background actually of where this comes from before we talk about how to solve these triangles. So this is what is called the ambiguous case when we have the law of sines. So remember that in law of sines you have to have an angle and a side opposite so that you can use that ratio to find the other parts of your triangle. When we have the ambiguous case, the word ambiguous literally means to have more than one possible outcome. So to have more than one option. So that's what we're going to look at, is when our triangle could actually have more than one option. Or in some cases, it could not even be a triangle. It could not exist at all based on the information we're given. And so we're going to start with where does that come from, what kind of triangles are we looking at, and then we'll talk about how to figure that out and solve for those triangles. So put aside all the trig for a minute, and we're just going to look at some basic triangle scenarios. So let's say I give you this information here. So I'm going to start with a fixed angle A. Okay, I'm not going to tell you how many degrees it is because the numbers don't matter right now. I have that fixed angle, and I have this side B that is a fixed length. Okay, so this angle A and this side B, that length and that angle are not going to change. Now, this bottom here, my horizontal line, is here just as a reference to give me the other side of my angle, but the length of this line could change. It's not a fixed length, it is in a fixed place because of this angle here. And so I want to look at what possible triangles could I have? What are my possibilities? And so in order to do that, let's start with probably the easiest one to think of, which is a right triangle. So if I want to have a right triangle, then I would start here in this point, because I know that for every line and a point not on the line, there is only one perpendicular line through both that point and the given line. Okay, so we know that about this particular picture. There's only one line here that's perpendicular, and the shortest distance between my point up here, okay, which would be point C on my triangle, okay, the shortest distance from this point to this line down here is going to be the distance that makes this a perpendicular line. That's what I wanted to do. Okay, so this would be one possible triangle. Okay, so one right triangle. I could have that as an option. So whatever length this is, this would make one right triangle. All right, so that's one possible triangle I could have. Another possible triangle that I could have would be, well, what if I have a line that's longer than that right triangle? Okay, so if I have a length that's exactly this green length here, then I'm going to make exactly one right triangle. But what if my line's a little too long for that? What if it's this long? Okay, what if it's too long? That's not going to make a right triangle. So in order to keep that length but make a triangle, I would need to swing this length up here to my line. See how that makes a triangle here? Okay. But at the same time, I could also take that same length, again. Let me draw it one more time. And I could, instead of swinging it left, what if I swing it out to the right and make a triangle out here to the right? So now notice I have two triangles possible. I have this exterior acute triangle, and I have this, I'll call it interior obtuse triangle. So I could possibly have two triangles. That's a little more like it. And since these lengths would be the same, this triangle I've made here in the middle would be an isosceles triangle. Do you guys kind of see that? Hopefully that makes sense to you. If this A is a fixed length, I could have this outside triangle or this inside triangle. So I could have two possible triangles here. Okay. So I have two triangles if length is longer than right triangle. Longer than it is for a right triangle. All right? So that begs the question, well, what if it's really long? What if it's, say, so long that it's actually longer even than B? So if I swing it up here to the left, it doesn't meet that line until all the way over here, right? There's no place where this point is going to be on that line. If it's on B, it's longer. So in order to get it up to the point where it's on this line, this horizontal line, I'd have to swing it all the way out here. Didn't work the way I wanted it to. Here we go. Well, then I'm not using this angle A right here. Yeah, that's not in my triangle. So in that case, I can't swing it to the left. I can only swing it out to the right. Okay. So if by chance A happens to be greater than B, okay, then I have only one obtuse triangle. Maybe that's not called obtuse. It probably is, but since I don't exactly know what this angle here is, we'll just say one triangle. One triangle where I have to swing this leg out to the right. Okay, so I have one triangle here. Okay, because A is too big to go to the left, it has to go out to the right. So if A is greater than B, then I only have one triangle. There we go. And then that brings us to our last one. Okay, if A is really long, then I have to have one. What if A is really short? So what if this length here is something like this? What if my length A is too short? In other words, it's shorter than what I would need to make a right triangle. So if A is too short, if it doesn't even reach down here to the bottom to make a right triangle, then I would have 0 possible triangles. No triangles. Okay? It wouldn't make one at all. So if I'm given this fixed angle A and this fixed length B, we can see all the different options if I know length A. If A is too short to make a right triangle, I have no triangles. If A is so long that it's actually longer than B, then I can only make one triangle out here with it. If it's exactly enough to make a right triangle, then I have one triangle. But if it's in between that right triangle length and B, then I actually have 2 possible triangles. And we would have to solve for all the parts of both of those triangles. Okay? This right here is the one where it's most complicated because we have to solve for 2 different triangles. However, we really first have to figure out how many triangles we're looking at. How many triangles do I have before I worry about trying to solve for them? Okay, so let's take this situation. I'm going to give you some numbers and we're going to figure out how many triangles we have before we go on to solving them. So let's say I take that same scenario. I'm going to draw myself the same picture we just had. But now I'm going to put some measurements on it. So instead of just saying angle A, I'm going to say that angle A is 35 degrees and side B is 14 units. Okay. Now you're also going to be given, in these cases, you're going to be given side length A. But I don't want you to worry about that yet. You're going to be given that pair. But in order to know how many triangles you have, you really do have to ignore that length for just a minute. Okay? We're going to check one thing on it, and then after that, we're going to ignore it. So the easiest part here, if we go back to what we just had, the easiest thing to check is if A is longer than B. That one doesn't depend on any other outside forces. Okay? It doesn't depend on anything else. Is A longer than B? And so let's say, for this case, let's say that A is 10. So number 1, is A longer than B? If A is greater than B, then you have one triangle. In this case, A is shorter than B, so I need to move on to the second thing I need to check. Okay? So always check that first, because then you can circumvent all the craziness we're going to do here in a second. So if A is greater than B, then I only have one triangle. Then that would only have to go way out here, right? Think back to that picture we just did. If that's not true, as it is not here, then I need to go on to my second part. So here's where I set aside my length of A for a minute, and I want to consider a right triangle. So consider having a right triangle. If this is a right triangle, I'm going to draw what that would look like. If this is a right triangle, I'm going to label this third side X. And I want to solve for X. Notice I'm not calling it A because I don't know if that's the right length or not. I don't know if A is going to be exactly a right triangle. But I'm saying, well, let's see what that would have to be. What would A have to be to make this a right triangle? Let's find that out. And we can do that using what we know about right triangles and right triangle trigonometry. And that would be that if this is my triangle, and I know angle A is 35 degrees, I have the hypotenuse of my right triangle, 14, and I have the opposite side, X. So using our trig ratios, the one we want to use that has opposite and hypotenuse is sine. So I would solve for X by doing sine 35 equals X over 14. Remember, we solve for X first on paper before we use our calculators. Then I would plug into my calculator 14 times sine 35, and I get that X is 8.03, and then it goes on 00 something or other, so 8.03 is good enough. Matter of fact, in this case, you could probably just call it 8. So I have my length of X. If this is a right triangle, then this length would have to be 8. Okay? But that's what I need to know is it a right triangle or not? So that brings us to our next conclusion that we can draw. If A equals X, this X right here, so if the A that I'm given equals this value of X, then I have one right triangle. Okay, I have this picture right here. If A is shorter than X, if A is too short to even reach the bottom, okay, if it stops part way, if it's only, for example, 6, then if A is less than X, I have 0 triangles. I don't even have enough length there to make a triangle at all. Then, if A is greater than X, but remember, still less than B, forgot my F, if A is less than X, but again, remember, it's also less than B. Did I say greater a second ago? I meant less. If it's greater than X but less than B, then I would have 2 triangles, because it would be too long to make a right triangle, and I could swing it one way or the other to make 2 triangles here. Okay. And so that's what we have to do to figure out how many triangles we have. Start with if A is greater than B. If not, then you have to start here. Consider your right triangle, solve for X, and then compare A to X to figure out how many triangles you have. All right, go back and watch that again if you're still a little stuck. Hopefully it'll ring a bell the second time around. And then watch our next video, which is solving for triangles when you have the ambiguous case.